All right, here's the first graphing question that came from 2023. So the actual exam question from 2023. This will be a question on your exam. So there'll be one question guaranteed that's going to be a graph and whether you can do calculus with a graph. So it's super important that we're listening. When I'm doing this, I'm going to go fastish, right? It's really important that you don't do it just to get done, but that each part that I do, you press pause and go back and do that part over again. So here we have a graph. The first thing I notice is that the graph is the derivative of f. And then as I read, I see f is there from -2 to 8. I'm given a point on the function and the graph of the derivative you see, and it has 2 line segments and a semicircle. And then there's going to be questions. And there's going to be all kinds of questions to deal with calculus off a graph. So the first question is, does the function have a minimum, a maximum, or neither at x equals 6? So what I'm going to do, and I'm going to do this on a separate piece of paper, is I'm going to draw a number line for f prime. And on that number line will be the x-intercepts, which are -1, 2, and 6. That's where the derivative is equal to 0. And then I'm going to put plus or minus, whether it's above or below. So it's above, so it's plus. Below, -2 to 6 above, and then 6 on above. And the question is there a maximum, minimum, or neither at 6? So look at it. So notice how the sign stayed the same. That means it's neither. So I got to make sure I read the question. So I'm going to write down x equals 6. F of x is neither a relative max or min Now, when it says this, give a reason or justify your answer, you have to say the word because. Okay? Write down the word because. So this is my answer. Because. Why did I? So you are thinking, oh, the sign stayed the same. How do I say that mathematically? And that would mean that the function is increasing and not changing direction at x equals 6. It's important to have words like increasing, decreasing, like math words that describe why you did what it did. It would not be good enough to say the signs stay the same. You have to describe what those signs mean, increasing or decreasing. So it stays increasing and does not change direction. Done. And that's 2 points. All right, that was part A. Part B. On what open intervals, if any, is the function concave down? So we have to understand that what we're looking for is the second derivative for when it's less than 0. That's what it means to be concave down. We write it down like that's what it means. So they can see, the readers, the ones that grade this, know I know what it means. The second derivative, when it's negative, that means it's concave down. Now, when looking off the graph, I'm looking at the derivative. So I'm looking at the derivative of a derivative. So if I'm looking at f prime, the second derivative, I'm looking to see where it's increasing and decreasing. If I'm just looking at f prime, I'm looking above or below. But the derivative of this, I'm looking, is it decreasing or increasing? So in other words, if it's concave down, I'm looking to see where it's decreasing. So where is the derivative decreasing? So from -2 to 0. So I'm using math words. So the derivative is decreasing where? We just said from -2 to 0. Where else is it decreasing? And it's decreasing from 4 to 6. That's it. And you give a reason, right? And it says, give a reason for your answer. So I'm describing it. I know the second derivative is negative. I know it's where it's decreasing. I'm telling you why in doing this. So even for this, I don't have to say because. I could say the answer and then the word because and then give a reason. You get a point for both, the right answer and the reason you give. Part C. I'm going to write it down right here. This is a limit question. When we have a limit that's a ratio, step one is to separate it. So I'm going to write down only the numerator, and I'm going to evaluate. So for the numerator, it just means plug in 2. 6 times f at 2, subtract 3 times 2. So this one's the tricky one. So on the side, I'm going to figure out what does f at 2, how do I find that? So I'm given the derivative. I need to know what f at 2 equals. So I have to go here and go, hey, f at 2 equals 1. It's given. I don't even have to find it. It's there. It's 1. So that's 6 times 1, and then 3 times 2 is 6, and then we do it. We do not, and we will not write down 0 over 0. The denominator, the limit as x approaches 2 of x squared subtract 5x plus 6. If you plug in 2, again, the answer is 0. We're showing that this is indeterminate. So we're going to use L'Hopital's rule, which means we're going to take the derivative of the numerator. So the derivative of 6 times f at x is 6 times the derivative of f at x. The derivative of negative 3x is negative 3. The denominator, the derivative of x squared, and the derivative of negative 5. I already know it's not indeterminate, because if I plug 2 into the bottom, I get 2 times 2 take away 5, not 0. So we're going to evaluate, or it doesn't exist. So when I plug in here, I'm going to plug in 2, and I'm going to solve it. Now I know it's not undefined because the bottom is not 0. So there is an actual number answer here. So what's the derivative at 2? Look off the graph. This is a derivative graph. So at 2, what's the answer? What's the y-coordinate? It's 0. So I'm going to go 6 times 0, take away 3. 2 times 2, take away 5. And then I'm just going to, now I actually, listen, let's just like practice this. Anything after this is no more points. If you do this wrong, you lose points. This is it. You get full credit right there. So writing negative 3 over negative 1 or positive 3 does not give you any extra points. It's over. All right, one more part. Part D. Usually for these free response questions, not always, there is going to be one part that's longer and uglier. Sometimes 2 parts. And it's usually the last part. Not always, but usually the part D is the one that's kind of longer and uglier. Now, sometimes it's part C or part B, and you need to be a good reader, because we need to make sure that when we're taking our exam, the shorter parts we do first, and if we have to leave D back and do it later, if I have time, that's what I'm going to do. All right, so let's do part D together. In part D, it asks for find the absolute minimum. If you're asked for the absolute maximum or minimum, that's a table of values question. So we're going to do a table of values for x and for f. And we're going from negative 2 to 8. So those are on my table of values. We also need to take the derivative equal to 0 and solve for x and see where the sign changes are. So the sign changes are at negative 1 and at 2. We're asked for the absolute minimum. 6 doesn't change that at all in there. It just keeps increasing from there. So we don't even need 6 on our list because there's no change at all. It's not a max or min. So we're good. So we have negative 2 and 8, and really the only candidates would be negative 1 and 2 that we need to include. So for each one I need to evaluate. So I remember, what does f at x equal? What do we have? So this is going to be the challenging part. So this is very common. They give you a point, and you need to be able to use that point and integrate to find values later on or before. So how do I set this up? And you're going to see this over and over and over until you're sick. And each question is going to have something very similar. So f at 2 equals 1. So our starting value is that y-coordinate. We're going to write down 1. And then I'm going to integrate using the derivative. Now, my bottom bound is always what I'm starting with. So at 2 as 1. So 2 is going to be my bottom bound. The top bound is what I'm looking for. So in this case, that's negative 2. And by the way, I already know the answer to this one. F at 2 equals 1. So I don't need to solve anything. It's already there. So we've already been told that value, so we only have to find 3 of them. So we're going to integrate from 2 to negative 2, the derivative. Now this would mean off the graph, I'm going to find the area from those 2 numbers. So the first thing I notice is the bottom number is bigger than the top number. That means it's improper. So all I have to do is this. If it's improper, start with a negative. If it's proper, start with a plus sign. That's it. So improper means it's still the same number area, but it's the opposite sign. To do that the easiest way, if it's improper, start with a negative parentheses, then just do your work. And then it will be the opposite number. So from negative 2 to 2, let's look at it. So from negative 2 to 2, I see a triangle. Feel free. This is what's tricky when it's digital, but we'll do it here. Negative 2 to 2. So I see 2 triangles. The first triangle is above the x-axis, so it's positive. So how do you find the area of a triangle? Half the base times the height. Beautiful. The next triangle is negative. So it's going to be negative. Remember, we were using parentheses, so it's okay. And this one is what? Base of through. Half the base, and then the height is 2. And that's it. Now, because I'm finding an absolute maximum, I kind of have to simplify it because I'm comparing the answers here. It's not my end answer, so it is worth my while to simplify. So 1/2 times 1 times 2 is 1. 1/2 times 2, or half of 6. And then if I completely simplify this, it ends up being 1 subtract negative 2, which is 3. So back here is 3. And now we need to fill in each one here. So the next one is 8. So sorry, this I should have said is f at negative 2. Whenever you write something on free response, it has to be mathematically correct, accurate. And if we're not writing something down that's accurate, we're going to get points taken off. Different than multiple choice, where you can do anything you want and they'll just tear it up and don't care what you wrote down. But for free response, they're going to see mathematically, they're going to see your work and see if it's accurate. All right, so the next one is f at 8. So for f at 8, again, it's the same setup. It's 1 plus, we're going to integrate from 2, but now it's 2 to 8. Now I want you to notice, it needs a dx here. I want you to notice that this is proper. So when it's proper, we put down a plus sign. When it's improper, we just put down a minus sign, parentheses, and get our answer. So from our graph, 2 to 8. So from 2 to 8, there are 2 shapes. So the first is the easy shape. So that's the triangle. Half the base times the height. So 1/2 times 2 times 2. Now the more difficult shape. Here, I want to find this area. This is not part of the circle. So how do I find this area with a semicircle? So it's not the area inside the semicircle. It's the area between the curve and the axes. Totally different. So I need to see this as 2 shapes. So the first shape I want you to see is a rectangle. And the second shape is the semicircle. And when you take the rectangle and you subtract the semicircle, what you're left with is the area I'm looking for. So what's the rectangle? How wide is it? How tall is it? It's 4 times 2, which is 8. Subtract the semicircle. So for a circle, it's pi r squared. The radius is 2. So I'm going to go pi r squared. The radius is 2. But because it's a semicircle, I'm going to divide by 2. Again, I'm going to simplify this. So I have 1 inside the parentheses. 1/2 of 4 plus 8. I'm just going to simplify it. And then 2 squared is 4 divided by 2. That's minus 2 pi. And then if I put it all together, I have 11 minus 2 pi. I'm going to put that in right here. 11 minus 2 pi. Okay, we're going to do this one more time for -1. So the setup. See how much longer this is taking? This is worth the most points. So we have 1 plus, we're going to integrate from 2 to what number we're looking at, -1. What do you notice is it's improper. So when I set this up, we're going to use a minus sign because the bottom number is bigger. And then I'm going to find the area in between here. So from 2 to -1. So here to here is just this triangle. We just already did it, half the base times the height. So it's 3 times 2 and half. So half the base times the height. Notice it's below, so it is negative inside the parentheses. So we have the first negative because it's improper, but then inside the parentheses it's negative because the shape is below the axes. So we have, what do we have here? Half of 6, and then when you subtract the negative, this answer is 4. All right, now I'm going to read the question again. It says, find the absolute minimum from there. What's the lowest answer here? So I'm not looking for the x coordinates. I'm looking here. 3, 4, and 1, or this one. Which one is the minimum in terms of it? So it's not 3 and 4, so it's either 1 or 11 take away 2 pi. So a quick, just say pi equals 3, not even 3.14. So 2 times 3, 11 take away 6, that answer is close to 5. That means our absolute minimum is 1. Done. That's it. And this work is justifying your answer. And you found the answer. When you're told to find absolute max or minimum, it's a table of values question. All right, you ready? You can press pause and go back to each part and do each part over again until you understand it. Not that you just finished your homework, but you understand each part because they're going to repeat again and again. So we're going to do one more question for your homework. Let me get another piece of paper out. Let's look at it. So the next question, just 2 questions. You would normally have 15 minutes to do each question. So the homework should take you 30 minutes, but it's not. It's taking you like an hour because we're working through it and trying to understand it. Maybe even more than an hour. What does it take? I'm given a graph. The first thing I look at is it's a derivative. I read the question. Again, I'm given a point to see how this repeated itself. This is 2022. The other one was 2023. Actual questions use like the same kind of question over and over and over. Notice what gets repeated. So anyways, f at 4 equals 3 is important. And you're given the derivative. And then it says find f at 0 and f at 5. And how would I set that up? So we have to start with the point that I'm given. So what's the y coordinate? We're going to do it right here. So this is 3a for the second one. So the y coordinate that we're going to start with, so again, we're given a point. So we're going to start at 3. We're going to integrate. And then that x value is always my bottom bound to what I'm looking for. And I should write down what I'm looking for. So I should write down f at 0 equals, so we know what we're looking for. So this upper bound is 0, and this is the derivative, always. Now, when I integrate off a graph, the derivative, I'm looking for the area. So we have 3. What do you notice? It's improper. The bottom number is bigger. So start with the negative, then parentheses, and then find the area from 0 to 4. So from 0 to 4 is a and it actually is a semicircle, hugging it. It's not the rectangle subtract. It's the actual one that I would find. So pi r squared, the radius of that semicircle is 2. And then divide by 2, because it's a semicircle. And that's it. That's my end answer. Like I don't need to simplify it because I'm not comparing that answer to anything else. Let's do the second part, which is f at 5. Same setup. 3 plus integrate. What I'm starting with, 4 going to 5. This is not improper. So it's going to stay a plus sign and then parentheses, and then I'm going to find the area from 4 to 5. So if I look from 4 to 5 and draw a picture from 4 to 5 right here, that's just a triangle. And so the base is 1 and the height is 1. And that's it. You can only make more mistakes after that. You don't have to simplify it. You're going to get points taken away trying to brag about it. Part B. And if you need to press pause and do part A over again until you understand it and watch the video a second time, a third time, then that's what you do. Find the x coordinates of the points of inflection for f. So first I'm going to recognize that the second derivative, right? And we need to know when the second derivative equals 0, and we need to draw a number line for this. So for the second derivative, so remember I'm looking at a derivative, so what does the second derivative look like? It's increasing and decreasing. So where does it change? Where are the turning points here? So there's only one turning point, which is right here at 6. So if I drew a line for the second derivative, the only critical number is 6, Before 6, oh, there's another critical number. I lied. Where's the other turning point here? At 2. So the derivative first is decreasing. That's negative. Then it's increasing. And then it's decreasing. And the question again, find the x-coordinates. So what are we going to write down? The x-coordinates are the x-coordinates of the point of inflections. I know I'm writing fast. We got to write fast and neat to a point. So the x-coordinates of the points of inflection are at x equals 2 and 6. Now, why are they at 2 and 6? Because it asks for justify your reason. So write down the word because and then say why you picked that. Because at, and it can be a run-on sentence. So what did we look at? You can either describe it with the first or second derivative. But we're saying more than the sign changes. We're saying the second derivative changes from positive to negative. Here we're saying the second derivative changes from negative to positive. We're seeing that it changes. Part C. We're almost done our homework. Let g be the function defined by this. So I'm going to write that down. G at x equals f at x equal minus x. And then it says, on what intervals is g decreasing? And so that question is a derivative question. Increasing and decreasing is first derivative. So that means I'm going to take the derivative. So the derivative of f at x is f prime at x, and the derivative of negative x is negative 1. I'm going to make it equal to 0. I'm going to solve it. So what I'm going to do is take the derivative, add 1, and when I look off the graph, where is the derivative equal to 1? So the y-coordinate is 1 at 7 and also at what number? So if you think of 1 and you draw a line through 1, what are the values where the derivative is equal to 1? So the derivative is at 5 and at 7. We're going to draw a number line. And then what are we looking for 5 and 7? Is we're looking to see if it's positive or negative. So how can I tell if it's before 5 or after 5, if it's positive or negative? So I'm literally, if I plugged in any number before 5, so like 4, and I go, okay, what's the derivative at 4 minus 1? So look at the graph. So the derivative at 4 is, what's the answer? It's just a graph. Find the y-coordinate. It's 0. And then what's 0 subtract 1? That answer is negative. Find a number between 5 and 7, like 6, and the same thing. At 6, what's the value of the derivative? It's 2. So it's 2 take away 1, which is positive. And then the derivative at, it ends at 7, right? Because there's no number after 7. So that's it. Because 7 is the last one here. It goes from 2 to 0 to 7. So I'm going to label this too. This is the derivative for g for the line, not for f, right? The derivative for g. And we found out negative, positive. And the question is, where is it decreasing, right? So g is, and you can just write down g. G is decreasing from 0 to 5, or you can write 0 to 5. And this is the reason why. You're showing the math reason why, so you don't have to write down the word because you already showed your math. All right, last part. And then our homework's done. And then you're going to decide if we're good or if you have to go back and redo it again and watch the video again. All right, for the function defined in part C, find the absolute minimum. Are you kidding me? What was the one before, the year before? Find the absolute minimum. And in that, so you're saying it like repeats and repeats and repeats. So when I have that question, I know it's going to take longer. So there's going to be a question that you won't know how to do anything on. I'm positive. Out of 6 questions, there's going to be one blank, maybe not blank, but pretty close to blank. So we're going to have to, when there's points to be had, we're going to have to spend time on this, because another question you may not get many points on. So here we are. We're going to do absolute here. So I need to know when the derivative is equal to 0. So the derivative for g, we just said this. What was the work that we just did? We just did the derivative. We did it equal to 0, and we found the answer is here. Where are our critical numbers from here? It was 5 and 7. So we already did the work. This was that. Take the derivative equal to 0. What does x equal? We did that work in the last question. I'm not going to do it over again. We have to do the ends too. So the one end is -2 and the other end is 8. And now for each one, I need to solve it. So we already know f at 2. So we need to know, so we need to know each one and solve each one. So I'm going to write down what g at x equals again. Sorry, it wasn't that. I'm like looking wrong. It's 0 to 7. This is all. I'm going back too many questions. So from 0 to 7, so what number am I missing then from 0 to 7? I'm missing 0. So we have 0, 7, and 5. Let me do this again. All right. We have our table of values. Our ends are 0 and 7. And the critical number there is 5 and 7, but we already have it on this. So there's just 3 of these. I need to remind myself, what's the definition again of g at x? And then I'm going to solve each one. So first of all, at 0. So f at 0, subtract 0. So just f at 0. So to find the value of the function, we go back to what we did in part A. So we need to realize we know a point, f at 4 equals 3. So we start with 3, we add, we do this integration. 4 is our bottom bound, and then what I'm looking for is the top. And did we already? No, we didn't. I think we did do this. In part A, didn't I do f at 0? So what was my answer in part A for f at 0? Why am I redoing my work? And then I didn't simplify it, but it was right here, right? 3 plus a half, so it's 3.5 at 0, right? Oh, it's right here. Sorry, 3 subtract 4 to 2 pi. That's the answer. 3 subtract 2 pi. Let's go here. We already did the work. So if you want to know how to do f at 0, go back in the video, which was part A. That was the question, what is f at 0? And we simplified the answer because I'm comparing answers. At 7, that one I actually have to do. So let's do at 7. So it's going to be 3 and then 4 to 7 of the derivative. And then we're also minusing x. So this is to find f at 7. And then we have to subtract the x value, which is also 7. So this is our setup. Now 4 to 7 is improper, so we're going to have a negative. And then what's the area from 4 to 7? So from 4 to, we kind of marked this up already, but from 4 to 7 I have a triangle and a trapezoid. So the triangle, half the base times the height. So it's 2 times 2 and half. This is all positive because it's above the axes. The trapezoid, 1/2. The base of the trapezoid from 6 to 7 is 1. And then we have 2 heights that we add up. So we add up 2 plus 1, which is 3. And then we put it all together. So inside the parentheses, half of 4 is 2. Half of 3. Decimals are okay. So it ends up being negative 0.5. Or negative 1/2. right, we got one more to do, which is at 5. Now, we already in part A did a lot of this work. So G at 5 is F at 5, take away 5. Now, we did F at 5 already. That was this one here, F at 5. We're going to simplify it. This is just 1/2 times 1 times 1. So it's 3 plus 1/2, which is 3.5. And then I'm going to read the question over again. Oh, is it improper or proper? No, it's positive 3.5, right? Or is it negative 3.5? Is there a negative in front of that? No, it's proper. 3 plus 1/2. And then the question is, what's the absolute minimum? So what's the lowest number here? It's a little bit tricky. Or is it 3 minus 2 pi? Or is this 3 plus 2 pi? What did I do? I know what I did. So here the area is negative. And it's improper, so it's a negative and a negative. I would have had it wrong. So if I simplified, a negative and a negative is plus, and then 4 divided by 2, this is actually 3 plus 2 pi, because it's improper and because the area is below. So I can correct myself. So this is 3 plus 2 pi. And again, I'm looking for the minimum here. For F at 5, did I make the same mistake? So F at 5 is proper from 4 to 5. So it is a positive area. It's 3 plus 1/2, 3.5. And you have to find the absolute minimum. Now I feel much better about it. So the absolute minimum is negative 1/2. And we show the work and show what's my least answer from my table of values. That's it. Mr. G Math over and out. We took 32 minutes and we had 30 minutes that we should because I made a little mistake, but we're right there. Remember, don't do it to do it. Go back and do each one over again so you understand how to do it. I'm proud of you.